Okay, cosine cubed x. Integrating this by integration of parts would be pretty hard. But what if we do is if we use our famous trig identity, 1 is equal to cosine squared x plus sine squared x. If we use this identity and then rewrite it and use cosine squared x is equal to 1 minus sine squared x. So this is the exact same thing, we just rewrote it differently. Now, this is cosine squared x, and this is equal to that. There's a cosine squared x in here, right? So we can write it as 1 minus sine squared x, 1 second, cosine x dx. So this is the exact same, all of this right here is cosine cubed. This is the exact same thing, all we did is use a trig identity. Okay, and now if we let u equal, so this is an important part, we should let u equal just sine, not sine squared x, not 1 minus sine squared x, and we shouldn't let it be cosine x, we should just let it be sine x. So if u is equal to sine x, then du is equal to cosine x dx, which is all very useful now because we can write our integral as 1 minus u squared. Now there's a cosine x dx here, and there's a cosine x dx here. So these are the exact same thing, right? And if they're the exact same thing, and 1 is equal to du, that means this is also equal to du. So we could just write du right here. And now we can definitely integrate this. This is a lot easier than this. So this is going to be u minus u cubed over 3. And again, if we had bounds, we could convert our bounds, but we don't have bounds because this is an indefinite integral. So let's just convert using this. So it's going to be sine x minus sine cubed x divided by 3. And of course there's a plus c, don't forget plus c. And all of this is exactly what cosine cubed x integrated is.